So what does it actually feel like to be on the front lines of the AI revolution? Well, we're about to find out. We're going to dive into some incredible insights straight from the researchers at OpenAI to really understand just how fast this is all moving and, maybe more importantly, where it's all going. So let's get into it.
And this quote, it really says it all, doesn't it? This isn't just hype you read in a headline. This is coming from someone inside the lab, someone actually building this stuff. And when they say the pace is absolutely amazing, well, that's when you know something incredible is happening. We're going to see exactly why they're so blown away.
All right, Section 1, From Not Bad to Brilliant, a 10-year journey. So to really get a feel for how fast things are moving, we've got to rewind the clock a bit. They say a decade in AI is pretty much like a century in any other field. And honestly, it's not an exaggeration. Let's take a look at what state-of-the-art looked like just a few years back.
Okay, check this out. This is a real story, something one of the OpenAI researchers actually talked about. You go back about a decade, and you give a top-tier language model a simple sentence. This movie is not bad. You and I know that means it's okay, maybe even pretty good. But the model? It just saw the word bad, and boom, labeled it negative. It completely missed the knot. Fast forward to today, and that kind of nuance is, well, it's child's play for these models. It's just one tiny example, but man, does it show you the insane leap we've taken.
And you can really see that journey laid out right here. GPT-1, that was the beginning, right? It could handle some basic language stuff. Then came GPT-2, and that felt like actual magic. The first time you saw it write a whole coherent paragraph, mind-blowing. But from there, it just went exponential. GPT-3 showed these surprising new abilities nobody predicted. And then GPT-4? That's when the researchers themselves started having what they call a personal AGI moment. It was doing things that genuinely shocked the people who literally created it.
Okay, so that brings us to our next chapter, Section 2, Cracking the Math Olympiad, a milestone in reasoning. This is where we see a huge recent achievement that kind of signals a whole new era for what AI can do. We're moving beyond just understanding and writing language. We're talking about pure, creative reasoning.
So, for anyone who doesn't know, the International Math Olympiad, the IMO, is basically the Olympics for the world's most brilliant high school math students. And these problems, they're not about just plugging in formulas. No, you have to come up with completely creative, novel ways to solve problems you've never even seen before. For years, AI researchers have pointed to the IMO as this sort of Mount Everest. It was seen as this ultimate test of true reasoning, a huge signpost on the road to AGI. And just recently, well, an AI reached the summit.
But here is the most stunning part of the whole thing. The AI did this with zero outside help. That means no calculator, no searching the web, nothing. It was all done with pure internal reasoning. Think about that for a second. We've gone from models that struggled with basic high school multiplication just a few years ago to this. It's a massive, massive leap.
But believe it or not, that's not even the most fascinating part of the story. The thing that really blew the researchers' minds wasn't just about the problems the AI solved. It was about the one it knew it couldn't solve. And that points to something much deeper than just being a good problem solver.
So here's the breakdown. The model just cruises through the first 5 problems. Solved, solved, solved. But then it gets to problem 6. Now, problem 6 is famously the hardest one, the one that requires a true stroke of genius. And here's what happened. The model didn't just spin its wheels and fail. It actually correctly figured out that it couldn't make any more progress. It basically knew its own limits. That level of insight, that's a stunning, stunning development.
So all of this brings us to a new and pretty fundamental challenge. Section 3, the limits of a test. What do we measure next? Think about it. If you have a student who starts acing every single one of your final exams, is the exam still a good way to measure how smart they are? Or do you need a new test?
And that's exactly the question researchers are asking themselves right now. If an AI can get a gold medal on one of the hardest tests humanity has ever come up with, is that test even useful anymore? All of these old benchmarks, these exams we created to track AI's progress, they're getting saturated. The models are genuinely hitting the ceiling of top-tier human performance.
So what's the problem with that? Well, first, we're just running out of tests. The models are genuinely getting that good. But there's a bigger issue. You can teach to the test, right? You can train a model to be an amazing test taker without it being truly intelligent or useful in the real world. So the focus has to shift. The real goal isn't about getting a high score anymore. It's about having a real-world impact and, get this,
actually discovering new things. And that pivot leads us to what I think is the most exciting part of this whole story. Section 4, automating scientific discovery, the next frontier. If mastering tests was the last chapter, the next great challenge is all about turning AI from a really good student into a scientist.
Yeah, the new goal is so much bigger than just building a better test taker. The real ambition now is to build an automated engine for scientific discovery. Just think about that for a second. An AI that doesn't just answer questions based on what we already know, but an AI that can come up with new ideas, test them, and make brand new discoveries all by itself. Basically, an automated researcher.
So the billion-dollar question is, how do we actually build that? Well, the researchers say there are a few key ingredients. First, just keep scaling. More compute, bigger models. That's a given. But here's a really crucial one: model persistence. That means giving a model the ability to just think about one really hard problem for days, or even weeks, just like a human scientist would. That's the key to going from answering a quick question to, say, solving a deep medical mystery.
And where would you aim a tool like this first? Well, the initial targets are some of the biggest challenges we have. You're looking at things like medicine, trying to radically speed up the discovery of new drugs. And then there's AI research itself, creating this incredible feedback loop where AI starts helping us build the next generation of AI. And so importantly, AI safety, using these super smart systems to help us figure out how to manage the risks that they themselves might pose.
Okay, let's bring all this high-level stuff down to a really practical level. Section 5, Advice for the Future, Navigating the AI Era. So what does this all mean for us? For anyone who's a student right now or just thinking about their career? The researchers actually had some very direct and maybe kind of surprising advice.
This was the message, loud and clear: you should absolutely learn to code. And I know what you might be thinking. Wait a minute, isn't AI getting really good at coding for us? Yes, but the reason for this advice is actually the most important part. It's not about what you think.
See, the real skill you get from learning to code isn't about memorizing commands. It's about developing what they call a structured intellect. It's the ability to look at a huge, messy, complicated problem and have the mental discipline to break it down into smaller, logical, solvable pieces. That kind of thinking, that skill, is going to be incredibly valuable no matter how good AI gets at doing the typing for us.
Which really leaves us with this final massive question to chew on. For all of human history, scientific discovery has been this slow, painstaking, gradual process. So what happens to our world? What does it even look like when we build a tool that can automate and radically accelerate the pace of discovery itself? It's a pretty profound thought, right? And it's the future that is being built right now, one breakthrough at a time.